Hi, Emily. Okay. All right. All right, so here we go. We're going to do a couple notes today. We're going to try to make sure the people at home can see this as I throw my keys on the floor. Does anybody, before I get started, not have the packet? Packet. If you forgot it at home, I can definitely get it for you. We'll be on the inside here in a second. But that's where we're going to be here first right now. But you do need a piece of paper. Good morning. Sorry at home didn't have that open, guys. That's a lot. Oh, look at all those people coming in. All right. Let's give everybody a moment since I didn't have it turned on correctly. All right. We will do this. All right. So all you're going to need today is you're going to need your packet. At the end of the period, there's a practice worksheet. You're going to need your notes wherever you're keeping your notes. And you are going to need your Chromebook at the very end to do your lecture questions and all that kind of good, and check the key if you would like. But we got Helen, we got Corey, and Emily's online. We got Jessica. Oh, and she wrote an email. All right, and then we got Caitlin. Here we got Lance. We got Amber. How was everybody's weekend? Good enough. All right, everybody is accounted for, and I'll take a look and see who is here online in a minute. All right, am I presenting there? I think hopefully everybody can hear me. It looks like my little mic thing is moving. All right, so we have talked about different types of matters, different types of matter all last week, and then there are physical and chemical changes and all that kind of stuff as well. So hopefully you're feeling good with that. Before we get too far into the notes, I would like to take a second and talk about the week schedule. Oh, this is frozen. The week schedule here. So today and tomorrow are your note days per usual. We're talking about separation of mixtures techniques and the law of conservation mass. We'll talk about a little bit tomorrow. Tomorrow will be like a wrap-up lecture, get a couple things, make sure everybody hammered home that they understand some stuff. On the 14th, I will do a concept map with you guys. I will tell you exactly what the test is going to look like. There is the review sheet. It's already in your packet if you want to take a look at it. And also Wednesday's folder is the key, all that kind of good stuff. So if you think you have to wait till Wednesday to start studying, you do not. But that's the day that we kind of have set aside to make sure everybody feels good for the test. And then your second test of the year will be on Thursday. We started to look at it last week. It's just really challenging to take a test that we had. I think it was 9 questions. It was no multiple choice. Everything was short answer. There were thinkers. There were demonstrations. It was a good test, and to try to take it and put it on to Schoology, and that people at home and here simultaneously can take it. So it's going to be nothing like my normal tests are, if you've heard of my normal tests. We'll have to find a different way to assess your knowledge. So right now, all I have is 15 multiple choice questions. And then we're going to flesh it out with a couple more questions that will hopefully allow you to think a little bit. But then again, with the limitations of Schoology, there's only so much we can do. But I would like to put this test onto quarter 1. I know that you're taking it on Thursday, which is technically the first day of quarter 2. But what we'll do, nobody wants to start the second quarter with a test. So we'll just tack it on to quarter 1. So if you really are looking at bringing up your grade, this will be a great opportunity to get that grade to go up if you were unhappy from the first test. Okay, but everybody's doing pretty darn good in this class, so I'm not worried about that at all. But just so you know, this is where we're headed: lecture, review, test, and then you don't have any school on Friday. Okay, perfect. And then we're going to get into, I guess I should throw this out here. We're going to get into thermochem next. Thermochem is very math intense, and it can be very challenging. Some of the spontaneity stuff, some of the stuff like that is very, very challenging. So we want to make sure that you guys are ready for the next unit. I would say if it's not the hardest unit, it's the second hardest unit of the year. Some students consider stoichiometry in the second semester to be the hardest unit, and some people consider thermochem to be the hardest unit. And the reason why I get differences is in thermochemistry, you can bring a lot of misconceptions in. So sometimes that makes thermochem harder. Stoichiometry is extremely mathy, and you've never learned anything about it. So some people think that's harder, but so they're the two biggest units of the 2 semesters. So the biggest unit of the first semester is coming up right after this, okay? Just a little heads up coming your way. So let's before we get there, that's the cart before the horse there. Let's go ahead and jot down. It will probably be right after intensive and extensive. That was the ending of our last notes. Matter notes, part number 3. We're going to talk about separating mixtures. We're going to talk about separating mixtures today. And we're going to go through 4 different techniques. Hopefully those of you at home will be able to see them. All right. I guess we're going to do 5 if you think about everything we're going to do here. All right. Here we go. Here we go. So the first thing we have to understand when we're talking about separating mixtures is that we're talking about mixtures that are together, and you have to know that that means that they are not chemically together, so we can separate them by physical means. Okay? Because mixtures are not chemically bonded, they can be separated by physical means. We're talking about boiling, filtering, chromatography, density, things like that. Okay, so mixtures are just more than one type of matter together. More than one type of matter together. But they're together physically. Okay, so kind of the one that I'm going to refer back to here, one of the types of things we're going to look at. I have some beads in some water here. Okay, water, beads, mixture. Let's figure out how to separate them. All right. So I would absolutely know that. And then the other thing, if it asks you on a test, quiz, assessment opportunity, if you are trying to figure out how to separate them, okay, what you want to look at are the different properties inside of whatever you have mixed together. So you want to say, all right, well, that's soluble and that's insoluble, or that's more dense or that's less dense, or that has a boiling point of whatever. To separate, you utilize the different properties of the materials in the mixture. I don't think you need to write the whole sentence. Just to separate, utilize different properties. Okay. You don't necessarily have to write the examples because we're going to go through examples here in a second, but you want to look at the different boiling points, the different densities, the different solubilities, things like that. And then you use any big differences to go ahead and separate. Just another thing you don't have to write. If you got a list of properties, choose the properties that are very different in order to separate. Like if you have 2 really different boiling points, but the densities are different, but not very far, you choose the one, because if they're similar properties, it will make it harder to separate. Okay. All right. So let's just do a little example. This one's not going to be on a test or anything. It's just kind of nifty. I learned this at a conference. Total cereal. Anybody have any cereal for breakfast this morning? You're like, I'm not a cereal fan, like eggs all the way. Okay. What are some things in total cereal? Why do they call it total cereal? Any ideas? Any ideas? Your total daily intake of what do you think? Yes. Thank you, First Period. Okay. All right. So one of the reasons why they call it total is because it says it has all that you need in vitamins, minerals, things like that. There's not a lot of extra sugar, stuff like that. Some of the things that are in here are vitamin A, vitamin C, calcium, iron. Okay. So there is iron in these cereals, and you actually need iron in order to have your blood and the hemoglobin in your blood actually work. So what we're going to do is we are going to try to tell you or show you that we have some iron in this cereal. Okay. So I'm going to pour some cereal in here. Put this to the side. And I know that everybody eats their cereal with milk, correct? But we're going to use water. It makes it look extra yummy. And then one thing about iron, okay? What's special about iron? Your refrigerator at home is made of iron. And what can you put on your refrigerator that sticks? Magnets, thank you. Okay, so the thing about iron is that it is magnetic. So what we can do is if there's real actual iron in here, I have what's called a stirring bar. And this stirring bar is a magnet, okay? And so people wonder how we make all the solutions that we do during the year. This is a hot plate and a stirring plate. So I take this magnetic stirring bar and he sticks on here because, again, he's magnetic. And then the thing is, when I want to stir a solution, it spins. Okay, so if I wanted to make something stir, I can put it in here and then it will spin. So I have a magnet that will be spinning inside of that cereal. Let's stop that for a second. Boop. There we go. So I put that magnet in there. Now the magnet's at the bottom. We're going to get that bad boy to spin here. All right. Now this is going to take a little bit of time. You're eventually going to see him start to spin the cereal. And we're going to let that cereal break down in that water. And we're going to see if we cannot pull out any actual iron out of that cereal. Okay. So we're going to let that go for a little while since, well, now he has an attitude. He's just jumping all around. Monday morning stirring bar. Should move him up. I should move him back so everybody can see. All right. So he's in here doing his little stirring thing. And we're going to give that a little minute. And we'll look at that at the end. Okay. So the magnetic stirring bar is clean. It has nothing on it. We're going to look at it and we'll come back after that mixture gets to separate. All right, so we have 4 ways that we're going to talk about that you will have available on your test on how to separate mixtures. 4 ways, okay? The first way we're going to talk about is called distillation. Distillation. You might have heard of distillation before. When you're talking about distilled water, things like that, if you were talking about in any of your environmental classes on how to get salt water cleaned up, things like that. Distillation separates by differences in boiling point. Distillation separates by differences in boiling point. So if you have a mixture of a whole bunch of stuff, and one of them has a lower boiling point, boop, you heat the substance until the one with the lowest boiling point evaporates away. Okay. And I have this set up. Good luck of us at home. We're going to try to see if we can't zoom you in over here. All right. All right. And what we're going to do today is we are going to distill some peach flavored pop. All right, people at home, I'm going to try to talk really loud so my microphone picks me up, but we'll see how this goes. All right, so everybody in the room, you can turn your attention over here. This is called the distillation apparatus. Okay, so what I'm going to do is I'm going to kind of start to get some stuff prepped here. I'm going to turn on some cold water. And the cold water is coming in through the bottom of this distillation tube, and then it's going up to the top, and then it's draining back out. So this tube is nice and cold. What's going to happen as well is there is an inner part to that tube that we're going to collect the gas, and the gas is going to condense. Okay, where that gas is going to come from is right here. I have a thing of peach pop. Okay, delicious, and very orange. Doesn't look like peaches at all. I'm going to pour some in here. Beautiful. Got it. And then I'm going to put her are what are called tamer tabs. You know, when things start to boil, sometimes they boil over, things like that. These are little pieces of rock that actually help things boil evenly. They tame the boil. So that's all these are. They're just to make sure it boils evenly. A couple tamer tabs in there. And then what we're going to do is we're going to take this. When I heat this, you will know that it will start to boil and it will go out the top, correct? What I'm going to do instead is I'm going to put this piece of glassware in here, and I'm going to divert anything that boils away down into this tube that I just showed you was cooled. Slide this over here. Let's flip this on so it doesn't get out too. And so anything that boils will be projected up and then down through the cooling tube, and it will condense and it will come out into this beaker on the other side, okay? So this is called distillation. You can put salt water in there. You can put any kind of mixture that you have that has two different boiling points, but today we're gonna do peach pop. Let's talk about what all is in peach pop. What are some things in pop? Water, sugar. Is this real color of peaches? Like, I don't know what kind of peach you eat, but it doesn't look like this. There's probably flavoring. There's carbon dioxide. There's lots of stuff in here. So what I want you to think about is as I boil it, what would go away and what would stay behind, okay? And we're going to get evidence of that here in a minute on what's going to come out here and we're going to collect, okay? The other thing I'm going to do, there's nothing tricky about this. This is just aluminum foil. And because it's rather cool these days, what I'm going to do is I'm just going to wrap this in aluminum foil to keep the heat in, just so it goes a little bit faster, okay? So he's got a nice little coat now. So now the heat's going to hopefully stay in and we'll be able to distill this quicker, okay? So we'll take a look. If you hear anything like totally like overflowing over here, tell me. Feedback. All right, so that's distillation. We'll come back to that and see what happens with that in a second. All right, distillation. The next one is called filtration. Filtration. There's a little guy doing it in here. Filtration. Filtration separates mixtures based on solubility and solubility only. Okay, so what happens in a filter, the insoluble substances, and this is the hard part because people, I'm going to ask you a question here in a second to see what you say. The insoluble substances in a solution will be collected. Okay, you cannot filter a solid that's just like a bunch of like salt and sand together. You can't filter that. It has to be in a solution. But the insoluble substances will be filtered out and collected by the filter. Okay? Wonderful. What I want you to think of is I want you to think of my beads and my water. So what I could have done is I could have distilled this, boiled it, the water could have gone away and left me behind my beads. What I could do that's a little bit faster though is I have a filter and I have my beads and my water. When I pour this into here, what's going to get stuck in the filter? The beads, and what's going to go through? The water. Okay? So when you're thinking about it, I want you to think about what's going to get stuck and what's going to flow through. Insoluble things will get stuck. Soluble things will flow through. Okay? So you're like, well, what does that do with beads? That's so silly. So what I'm going to do is I'm actually going to make you a precipitate. We talked about precipitates last week, that they're solids that come out of solution. So I have some, is this a magnesium sulfate? I have some magnesium sulfate, which is a clear liquid. And I have some sodium hydroxide, which is also a clear liquid. But what's going to happen when I put them together is I'm going to make a precipitate. So I'm going to do this up here so that everybody can see, hopefully, and my peeps at home can see. Okay, when I add these together, all of a sudden, I get a cloudy white substance. Okay, and that cloudy white substance is called a precipitate. It is a solid that was formed out of solution. So in all the labs we do this year, where you make precipitates, and there's a lab where we say you have to make this exact amount of the precipitate. So just like my beads in water, if I want that solid out, I use what's called a piece of filter paper. I'm going to fold it in half, fold it in half. We'll teach you this when we get to the lab, how to fold filter paper. Boom. Now I have a filter, and what's going to be staying behind are my insoluble pieces, okay? And then anything that is soluble in the water will then go through. So we're going to give that a second. You'll be able to see that go here in a second. While we're doing that, I have a bit of a thinker. If I have some food coloring in water, okay? Oh, works well for large quantities. Well, for large, and it's pretty quick. I have food coloring water here. I'm going to try to filter that out. Do you think that food coloring will filter out of water? Will the food coloring get stopped in the filter? Yes. No. No. Yes. Who knows? Let's get these beads out of here. Get out of here, beads. Oh, I'm okay. I'm all right. All right, so I got my filter. Just drop my keys. That's okay too. Here, okay. As you can see, what's coming through in the bottom here, this is just clear water, and my white precipitate is being stopped in the top. Now, this is a clear, clean beaker down here. I want you to think to yourself whether or not, if I filter out food coloring, that'll be stopped by a filter. Okay? Remember, the filter only stops insoluble substances. Let us find out. I'm just going to take a second to do its thing. Beautiful. Hopefully you guys can see that. Piece of paper here. Hopefully you at home made a guess too. Is this stopping the food coloring? Why is it not stopping the food coloring? The food coloring is soluble. So can I filter salt out of salt water? Salt is soluble, okay? So that's one of the main reasons why we have a really hard time kind of cleaning up some of our water, because if it is soluble, you cannot filter it. If it is dissolved, it will go right through a filter, okay? So that's what we're looking at here. Pretty much, if it is going to be soluble, one of the only things you can do is distill. Okay, if you come to a test question and it's like, hey, this is soluble, you're kind of looking at distillation. And as you can see here, still got some clear water dripping through here. My solid precipitates there, and I'll show you that at the end as well. The one big thing about mixtures is they take a while to separate sometimes. All right, so those are, so no, because the food coloring is dissolved. So hopefully you guys feeling that. Let's do two more, shall we? Two more. The next one's called a centrifuge. 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 Good. Get my little guy going here. The centrifuge works a little bit on solubility, but it also works on density. Separates by density and solubility. Beautiful. Separates on density and solubility. We got anything for that? No. Oh, we're getting close. Pull it on the way. There we go. All right. So what happens in a centrifuge is that it spins and the insoluble substances, excuse me, the insoluble substances spin and the more dense particles settle out. Okay, but again, in order to separate this, they need to be insoluble. Have you guys ever been on one of those carnival rides where the thing spins so fast you stick to the walls and then the bottom drops out and all kind of good stuff? That is almost exactly what happens in a centrifuge. Okay, beautiful. So let's do, this works well, but it's fast, but you can only do small quantities. Just a heads up. Okay, so I'm gonna turn my keeps over here. Okay. All right, so I have my precipitate still. Whenever we have the centrifuge and we're using it in class, it will always be in the fume hood. This is a centrifuge. You might see things like this in the movies and in TV shows and things like that. In here, okay, are a bunch of slots that fit centrifuge tubes. So they're special tubes that you use and they go in here, and then what happens is this thing will spin, okay? And as it spins, the more dense particles will spin to the bottom and the less dense particles will spin to the top. You might have used this in PBS or HBS or anything like that. When you put it in here, there is a number. You want to make sure you look at that number because people are like, oh, mine's the one on the left. And then it spins. And you don't know if it comes back there, okay? So what I'm going to do is I have my precipitate, which is a solid in there in solution. I'm going to pour some of it in here. And as you can see, the whole thing is cloudy and white. The whole thing is cloudy and white. And I'm going to put it in my centrifuge. The thing about a centrifuge is it's like a teeter-totter. You can never have just one side have something or else you'll break it. So just for giggles, I'm going to put food coloring water on the other side. And that's not very stirred. I just put a drop in there this morning. Let's stir it up before it looks like something happened that didn't. Good stuff. So I have green water, and I'm going to put that in the centrifuge as well. So we're going to see which separates and which does not. So they're across from each other. Close this, turn this on. You'll hear it start to spin. Woo. It goes very quickly. It is spinning at a high rate of RPM. And anything that is insoluble and more dense will settle out to the bottom, okay? And less dense, insoluble things will go to the top. Perfect. That's probably good enough. All right. Then it sounds like a cool little microwave, makes a little ding sound. Wonderful. Now you want to wait until it's done spinning. You know, if you stick your finger in there, it gets stuck and then it rips your finger off and then just blood everywhere. It's tough to clean. Nobody likes to do that. At least somebody kind of laughed at that. All right, so then we're going to open it. It's still spinning very quickly. And these goggles are fogging up. All right. This one's the more powerful one. I like this other one because it's a little slower. All right. Now, what you can hopefully see is my solid white precipitate has been thrown to the bottom, and I still have my clear liquid on the top, okay? Solid white precipitate is on the bottom. Clear, the rest of my solution is on the top, okay? So solid, insoluble. Do you think that my food coloring and my water got separated from each other? Nope. Why can't food coloring come out of water? Because it is soluble. Okay? Very good. That's a toughie. That's a toughie. All right. Next one. Last one. chromatography. Chromatography. And chromatography is separation based on color. I think you do this in biology. You might do it in 9th grade or in middle school, things like that. All right. So what we do with chromatography, I guess I should show you first. Chromatography requires a special paper. And if you see here, I have my chromatography paper and I have 4 different colors. And what I can do is you're going to run water through this chromatography paper. Did you guys ever do this lab before? I feel like students did this lab before because I used to do it. And what's going to happen is the water is going to come up through the different colors of marker and we're going to pull out all the different colors. For instance, you know that like green is made of 2 different colors, things like that. We'll be able to pull that. So that takes a moment as well. So chromatography, substances that are dissolved easily travel the farthest. I don't think you really need to know that. Okay. But the biggest thing, we'll take a look at that in a second. We'll take a, oh, we got some good stuff over there. We'll take a look over there, all that kind of goodness. What I want you guys to do, as I'm going to kind of show you the rest of these pieces and parts that we kind of had started here, I want you to go ahead and the worksheet that you have here, where did it go? Separation techniques, bell work. Get started on that. Also, get out your Chromebook. We have about 7 minutes. I want you to do the lecture questions right now. And I'm going to turn your attention over to my distillation device. All right, distillation. Let's talk about it. What color do you think the liquid that came out of the peach pop is? Any guesses? Basically, you're going to have a guess of clear or peach. You know, because you were over here. This is actually a clear liquid, okay? So what that means is that the food coloring itself must have had a higher boiling point than the water, right? So a lot of students think that this is just water. However, I usually pass this around and you usually smell it. I guess we might be able to smell it through your hearing. Okay, we're not going to walk. Just give that a smell. Can you try it? Can you do it for us? No. Can you smell this? Take it through your mouth. What does it smell? Is it water? It smells like peaches. Can you smell this? Can you smell this? Give it a smell. Still smells like peaches, okay? So the thing is that what must have had a low boiling point in there must have been the water and must have been the whatever flavoring or whatever they do to give it the smell. Does that make sense? The sugar is still in there because that's a solid. The coloring itself is still in there, but we distilled out the water and the peach flavor. Okay? Perfect. All right. Now let's take a look up here. You can see I had a green dot that has yellow and blue in it. This is chromatography. Okay? Chromatography. And let's see if my solid precipitate, my white solid precipitate, it's not exactly done, I'll call it a day, is stuck in the top here. I have my clear liquid that came through at the bottom here. My people at home can't see that. Let me back up. Okay, and then let's take a look here, last but not least, at my delicious, where'd you go, stirring bar? There you are. Stirring bar. Got a little sample right over here of iron. I'm going to take, I have a control that doesn't have any iron on it. And then I have, so this is my control, if you can see at home. And then here is the elemental iron, the pure iron that we pulled out of the actual cereal itself. So you can see this is iron shavings here that we pulled out of cereal because we didn't have any on before. Iron shavings we pulled out of cereal right here. We got some iron. So we pulled right out of the cereal. Some pure iron. We pulled some iron out of that cereal. It didn't have any iron before. Iron. Don't tell me it's not open. What? Uh-oh, too many yours worked. Oh, you know what schooled you was being a huge turd earlier today. Here you go. A little elemental iron. This elemental iron came right out of that cereal. Elemental iron. Perfect. Perfect. So go through, do your 3 lecture questions, and the worksheet. The worksheet's going to give you some examples, like on the test. If I say, hey, you have a mixture of X, Y, and Z. The interesting thing, let's do number, whatever the first one is on the front. Given the information below, explain step by step how you would separate each material. Include the separation techniques for each in order. So you have a mixture of styrofoam beads that are solid, not soluble in water, and they have a light density. You have some iron shavings or whatever, solid, not soluble in water, and they have a heavy density. You have potassium bromide, which is a solid, and it is soluble in water, and then it has a density of 2.66. So we can look around water because we have water here. If I were to first put water into the beaker, okay, looking at what I have, would anything dissolve? If I put water in that beaker, would anything dissolve? Is there anything up there that says it's soluble in water? Beautiful. Okay, so the first thing is your potassium bromide would dissolve. Would any of these things float in water? Okay, good. So then think about how you can separate something based on density. Then after you've gotten that out, is there another solid that you might be able to use filter? So this will use 3 types of the techniques that you would need. So I have 2, 3, and 4. Okay, so that one's one of the harder ones there. And then on the back are some easier ones on how to separate in different steps. Okay, hot dog. We have about a minute left. Make sure you do your lecture questions. Make sure you do this worksheet so you know what kind of questions you would see on the test. Awesome. Okay. Does anybody have any questions? Good. All right. Thank you guys at home. It's going to ring in about a minute. Oh, I didn't take attendance at home. No!